to Revolution in Physics, video 19. I'm going to talk about acceleration and velocity a little bit, and this whole idea of cutting it down to the basic elements, these photons that are making stuff happen, and such. But first I'll read one comment on the last video, and you know, it's okay. It's going to be the last one from this guy, Rick. Anyway, last one from me because I give up. You can describe an electric field with integrals, and you can build complex systems from that by exactly calculating what fields you have in which points of space, or you can describe them as a school of fish. Well, I'm just saying, you're saying the fields, we should just accept this idea that fields are just magic. There's just magic that makes things happen. Magnets are magic, and gravity is magic. And there isn't something in the force. The force isn't made out of anything. So yes, maybe I'll title this video, Fish Are Force. Our force is fish. Yeah, F equals F. Force equals fish. Because it's something. Something moves, and it bangs into something else and causes it to change, and then it moves, and then that bangs into something else and causes it to change, and it moves. Yes, I'm saying that as you get cruder and deeper into the mechanics of the universe, it gets less mysterious, not more mysterious, and then it gets simpler, not more complicated, and that underneath it all, it's just a bunch of stuff banging into stuff. And it's stuff. A force is a stuff, not a field. It's a field of stuff. Anyway, fields are fish. Maybe that would work better. I don't know. For I have seen the shadow of the earth on the moon, and have more faith in the shadow than in the church. Well, gee, what does that mean? So this is a religion. It's based on the dogmatic edicts of a supernatural being who declared commandments. I command that you believe the universe is rational. yeah, that it makes some kind of sense rather than just making up multiverses and silly mumbo jumbo. I just saw like an hour of and a half of a Mishu a cuckoo. Yeah. Mishu a cuckoo. Well, anyway, it doesn't really matter. Kook, he's a kook. String theory, UFOs, I mean, it's all just, and you're going to call me the religious nut. Oh, sorry. And I have seen electromagnetic theory. I don't even know what that means. You know, what is that theory? What is that? I mean, please. Used to build mobile phones. So, well, at least you didn't say, quantum theory. Yeah, I've worked, okay, in a machine shop. I've worked in a place that built electronic devices, control devices, computers, robots. And you know how you know how stuff is made? You try things, trial and error. That's how the mobile phone was created. Is people said, oh, you got to make it run on less voltage. You're gonna get less amperage, and we got to get this thing smaller and smaller and smaller. And so they just kept trial and erroring. And I have more faith in the ability of my mobile phone to use an electromagnetic wave. Well, again, I don't think the guys who engineered it are worried about any electromagnetic wave. They're worried about electrons moving in a wire and how hot that gets, and getting it to go across a piece of silicone without fracturing it, and that kind of thing. So, for communication, then in the theories of draft science, well, whatever. I have no confidence that you serve any useful purpose on planet Earth. There, it's just an honest statement. I just bet you're a naysaying, nitpicking asswipe who just does everything Mommy told you to do and thinks everything Mommy thought. You have no imagination. You obviously find it offensive that somebody would apply any imagination, because you have the right God. Einstein is God. Feynman is God. You can't know it. They told you that you can't understand, and therefore you believe them. Well, that's your problem. So anyway, moving on. So there's just two elements of these interactions that take place. It's kind of interesting. The difference between an acceleration, so I guess we have to have some sort of like push symbol for that. Like acceleration is a push. And then you got something called its velocity, you know, what it maintains. So it's this idea of how does something maintain its movement. And so I've sort of argued that there has to be something in the matter. Okay, let's get to the basic root of it. Is that space is a cube, let's say, of, you know, all the whole universe is just a gigantic, you know, cubic universe. It's all a bunch of little squares, little cubes. You know, you can draw the cube, little cube image, but you know, it's all cubes of space. Planck cubes, you could call them. And things can, you know, all these cubes, there's traffic in the cubes. Okay, there's photons that travel essentially as a change in the status of the cube. The cube is either a photon or it's not a photon. There's either a photon in the cube or there's no photon in the cube. And every whatever zillion milliseconds the photons move. They move on the cubes. Now the question is whether there is an actual clock speed of the universe, like everything has to move on the clock speed, everything has to move on the tick, or whether they can occupy cubes and then something else has to do something when there's a cube in the space that they were heading for. And that's sort of this argument with this kinetic thing, which I've been thinking about. But there's different ways to see how a kinetic interaction would take place. So let's just say from the two entities, say this was going this way, it could be part of a big circle, you know, so it could be part of an electron, and this thing is going this way. And so you could figure out their interaction. They would, you know, step 1, step 2, step 3, they're both moving the speed of light, but they would have to be moving the speed of light also in the same, they'd have to be synchronized, right? In the sense that this one might, you know, a half of a Planck time entity, or a Planck, you know, the one of them could be halfway into the space. But it's sort of an all or nothing system, let's just say. They either flip all the way or they don't flip. There's no half a flip. So they're either occupying a space or they're not occupying a space. So you can make, you know, there's subtleties to the argument, and it makes a difference in terms of how you decipher those subtleties about what actually happens in these interactions, these kinetic interactions. So you could argue that a purely kinetic interaction would be that the two things come together, they both wish to land on the same space, let's say, and you know, to do that, you either look at it as they do it on the fourth click, which is the third click for one of them. You know, one of them occupies the space, the other one goes, connects, hits through it, and passes through it somehow. And you know, you can see it as being something where nothing changes. You know, somehow they both occupy the same space in the same time. So in the same time, they both have to be in the same exact space. In the sense that, see, if 3 jumps to 4 here, so there's a jumping over this space. So what I'm saying is there's a loss of a space. This space got used by the 3 here, but this one jumped over it. So there's been a loss of a space technically. You see what I'm saying? So if you put the space back in and allow the kinetic interaction, well then one of the entities, you know, the one going this way or the one going this way, has to change in terms of it gets pushed slightly by the interaction. So if this was an electron, you could see how it would be migrated in a direction by that push. It would be moved one Planck constant in a direction by that push. So it's a way of seeing that there's, you know, there's a subtle difference between how you interpret how kinetic energy could possibly really be transferred perfectly efficiently, in the sense that everything stays exactly the way it was through the interaction. And that might be difficult to resolve, whether there has to be some sort of construction, there has to be some difference because of the interaction. There can be, anyway. So, I mean, a subtle thing like that would certainly account for the creation of acceleration, or the acceleration, or the idea that energy goes in, and that you could theorize that if a single photon hits and does this kinetic thing where it just pushes the orbit of an electron one Planck constant distance, it might not be significant, but if there's a frequency, a constant bombardment, that these might hit before there's the compensating change in the orbit, before there's the bigger bite at the other end, and that might warp the shape of the orbit, and that a change in the shape of an orbit could make a change in what it might be doing as a pattern. So the difference between velocity and acceleration is when acceleration creates a pattern of movement, and that's sort of what you see with gravity in a vacuum. Would be that there would be a pattern. The acceleration happens, it changes the form of the matter keeps moving in the direction already acquired, it's already eating more space, and then there's more acceleration which gets it to eat more space, and so it just keeps going faster and faster because it never loses what was put in. So you could argue that, you know, an accelerant would just push something, it would move the amount it was accelerated and then stop because it used up the accelerant. The accelerant went through it, it moved it one step forward, like here. You could kind of see where it moves it one step in a direction, but that's it, it's one step. There's no indication that it's going to keep on moving in that direction. If they were photons moving the speed of light, they still need a mechanism that would require them to keep moving. And so I think that's where you just come up with some idea that there is this idea that somewhere built into the system is this idea that it eats a little bit of space by nature. The nature of an electron is to always be eating a piece of space, and that the real game is just pushing it in an orientation. So changing the orientation of this opening is really all that's taking place. And so the question is if it's moving in this direction, how much energy is required in this direction to push it, to get it to start moving in another direction where it'll eat space in that direction. So that's the momentum of this circle. You could almost argue that changing this angular momentum, the angular momentum of electrons, is fundamentally what drags everything else along. So if you change the angular momentum of the electron, however else it's connected to these other things, it will force them to also be dragged along with it if it's bound to them. And it's just a question, if you force it too hard, if you hit it too hard, it's not going to push the rest of the stuff with it, and it's going to be broken free. So this is the nature of something I have to make more precise or clear, is understanding how momentum is changed in an electron, and let's say it already has an established momentum, how a new momentum is created. How do you alter its momentum when, like I said, if the opening is in this orientation, how do I change that opening to this orientation? So now it's eating space in this direction. So if it's wobbling this way, can just hitting it this way is just going to move the wobble this way. What has to change is you have to tilt the wobble. You have to get it at this angle to change. You have to get it to wobble in a new direction. And so that's something I have to work on. But that really has to do with the nature of, whether this is a complete circle or it could be a more complex spiral. And so depending on where the energy comes in, could change where the energy goes out. And what it is that you're hitting. So anyway, that's where I'm sort of just stuck. I mean, this idea works for gravity in the sense that you could say, okay, it's just these photons come in, they make a tiny subtle difference in this circle, this orbit, and that small difference, over the whole mass of over the whole mass can move very big things, because there's a little tiny difference being made by this constant pressure of photons, and when the photons from the opposite direction are stopped, there's going to be an uneven amount of pressure, and it's going to push things in a direction. But the idea is still, why would it maintain this new position? Is more than a new position, it's a new momentum. So again, it's this change in momentum of the spiral itself that I have to account for. And we've worked on different explanations for that, but they just all don't, they're not good enough yet. But yeah, it just seems like the basic mechanism, that this is the nature of the mechanism is something like this. I mean, this does, in my opinion, explain so much of this, the distinction between a single photon hitting and the idea of something at a frequency hitting, and how, depending on how quick the frequency is and how big the electron is in terms of its orbit, that you'd have a bigger or lesser chance of hitting it, twice or 3 times before it makes one orbit through its diameter. So before it can get through its diameter from this side to this side, you've impacted it, and that creates three Planck constants of force, which might be sufficient to break it free of the bond it has to its nucleus, to the proton and the neutron. So anyway, but this is all to be worked out eventually. So yeah, so that's just where my head is. I mean, I'm liking that the visualization. I'm just not liking that I still have to account for the change in momentum is the key thing. But it's clearly, that's a huge part of quantum mechanics, is the change in angular momentum in the interaction between photons and electrons. That's what Feynman diagrams are basically a description of, is the change in angular momentum. And I just have to, I'd like to come up with a visualization of how that exchange takes place. And it's clearly not dependent on any kind of straightforward kinetic interactions. It does seem like the kinetic interactions are they fit into this idea of a range of possible angles, degrees of interaction. Something like that. More than one way to interact. That's the way to put it. It might only be 4 or 5 ways, but there's 4 or 5 ways that create this probabilistic problem. So anyway, I'll get to that. So, connecting all the dots, it's going to take some time to make that perfect, but yeah, I'll work on it. I have some other things on my list. Yeah, so I did write down, these are just new talking points. Just don't know if I would need to mess with any of these right now. Frequency is the period between photons. These are simple things, but these are things that most people don't see it and don't realize that, that's the distinction. That the photons are all equal. What's different is how often they arrive. So anyway, I mean, you can almost argue that radio waves are a front of photons. That's what makes their energy big, is that they're so wide in the exposure, and that when you get to the higher energy photons, they don't have that big wave front. They're usually ray-like, in like X-rays. They're more like a stream of energy. So it's like the difference between a wave of slowly arriving, a crowd that are a bunch of fish that arrive in slow waves, versus a stream of fish where they machine gun at you. But you could have the same amount of energy in both. It's just that in one circumstance the energy is spread out over a large area, and the other one the energy is all concentrated on one thing, one tiny pixel of space. So anyway, yeah, enough. Till next time.